Adaptive Planning Strategies for Rural-Urban Transformation in Ethiopia.
Case study of a 10,000 inhabitant city presented by Franziska Paul and
Henriette Goldbeck.
The area is located in the Kewet district of the Amhara region in Ethiopia, on the edge of a plateau in the highlands with a height over 3,000 meters.
Since the education of the population determines the future of the city and the society, the heart of our concept is based on the school. Regarding the urban condition, we determined 3 different specialties of schools: school with an agriculture focus, school with a commercial focus, or school with a handcraft focus. These schools are characterized by distances from the existing typology. In this way, we can easily change the location of our school regarding its specialties. The location of the school is then used as a basis for the distribution for the other uses.
Our planning strategy is based on 7 layers: the site analysis and boundary setting, the creation of a street network, the choice of a school focus and location, the main use distribution, the distribution of the special uses, the development of building typologies, and the setting of trees.
Our site is connected to the surrounding area by the main road, which is also the only large infrastructure. In the last years, a smaller settlement center and an industrial site developed along this main road. To the sides, the city growth is limited by strong topography in the south and by a narrow river with high flooding risk and fertile agriculture in the north, as well as 2 very prominent green hills that are farmed, which we would like to preserve. To avoid a strong slope and minimize the flooding risk, we also consider the catchment area and align the boundary along the contour lines.
The next step was the development of 3 different street networks we used to test our concept. All these networks are oriented perpendicular to the contour lines in their own way for minimum wash-up and flooding risk. Furthermore, they already consider the existing industry with providing an area for expansion.
The first step for the distribution of our schools was to set up rules. These rules were transformed as inputs in our Grasshopper script to create attractivity maps that generate the highest attractivity for each school typology in each street network.
The next step is the distribution of the main uses: urban agriculture, residential, and commercial. Therefore, we also set up rules to create attractivity maps. These maps are then used as inputs to a loop where we could value the different attractivities with thresholds based on their importance for each main use. The output is then the distribution of main uses. Urban agriculture, which is also along the boundary in zones with higher flooding risk, has the lowest density, an AFAR of 0.4. The residential area has a medium density, an AFAR of 0.65. And commercial area, as a denser center, has a FAR of 1.5.
The last step is the distribution of the special uses: religion, hospital, and market. Thus, we set up rules for their location, transformed them again into attractivity maps, and generate thereby the distribution.
With the final distribution of all uses, we could place the different building typologies on the plots and add trees.
With our Grasshopper script, we automatically created 9 different versions with even more possible outcomes by changing thresholds for some criteria or adding another street network. Thus, the evaluation of the outcome is important to compare the results and identify the best fitting solution for different requirements. The criteria we analyzed were washout risk, flooding risk, cost of street network and water pipes, percentage of commercial plots located along lively streets, average distance to school for the surrounding settlements, and average distance to school for inhabitants of the city, length of the main street that is needed for the different schoolways, percentage of needs to cross the main street on the schoolway, the complexity of the street network measured by angles you need to walk around, and streets with a maximum slope of 6%.